Hello, welcome back to my channel. In the previous videos, we got to know that 1 mole of a substance has 6.022 times 10 raised to the power 23 particles in it. We also saw that that amount of substance, that number of particles, the mass of that number of particles is what we know as the molar mass. Therefore, the mass of 1 mole of a substance is known as molar mass. But when we talk of gases, we normally use their volume to measure them. So they are normally known and measured by their volumes. So the question will arise, what will be the volume of a gas that contains 6.022 times 10 raised to the power 23 particles? So, what is the volume of 1 mole of a gas? How much space will 1 mole of a gas occupy? Now, Avogadro in his works saw that if you keep the temperature and the pressure constant, then the volume of all gases will be the same if they have the same amount of substance, which means that if you have zero point 0.1 moles of hydrogen gas or carbon dioxide gas or ammonia gas or sulfur dioxide or hydrochloric acid, if you have their gases and their mole is zero point 0.1, that implies that all of them will have the same volume. If the mole is zero point 0.2 for all of them, then they will all have the same volume, provided the temperature and the pressure are kept constant. And by so doing, he determined that if you take 1 mole of a gas and you state the temperature and the pressure, so the standard temperature and pressure, then that volume, that amount of gas, that is the 1 mole of the gas, will have a volume of 22.4 decimeter cube, which is also equal to 22,400 centimeter cube, or 22.4 liters, or 22,400 milliliters. So, in mathematical terms, the molar volume, which is defined as 1 mole, which is defined as the volume of 1 mole of a gas, is the volume of the gas over the amount of substance, which is the mole. And if we use the symbols to represent them, then Vm, which is molar volume, is equal to volume over mole. And if you change the subject and make mole the subject, then mole N is equal to volume V over molar volume Vn. Now let's also note that a gas that has 6.022 times 10 raised to the power 23 molecules has a volume of 22.4 dm cube. Why? Because 1 mole of a gas has 6.22 times 10 raised to the power 23 molecules. So if 1 mole of a gas has that number of molecules, it implies that 1 mole of a gas will contain 22.4 dm cube as the volume. Let's see how we can this can be applied. So what volume will 0.238 mole of CO2 occupy at standard temperature and pressure, given that molar volume is 22.4 decimeter cube per mole? Now we know that 1 mole of a gas has the volume 22.4 decimeter cube. Therefore, what will be the volume occupied by 0.23 mole of CO2? And that will be the 0.23 mole of the CO2 times the molar volume, which is 22.4, and that's all over 1 mole, which is the mole of the gas, and that will give you 5.33 dm cube, which means that 0.238 of CO2 at standard temperature and pressure will have a volume of 5.33 dm cube. Let's check the next question and see. How many molecules of ammonia will occupy 2.35 decimeter cube at STP, given that molar volume is 22.4 dm cube per mole? Again, we know that 22.4 dm cube of a gas will contain 6.022 times 10 raised to the power 23 particles or molecules. And so, what will be the amount of molecules or the number of molecules in 2.35 dm cube? And that will be the 2.35 dm cube times 6.022 times 10 raised to the power 23 all over the molar, and that gives us 6.32 times 10 raised to the power 22 molecules. I hope you enjoyed this video. Kindly subscribe and click on the notification button so that every time I upload a video, you will get the notification so that we'll learn together to make sure chemistry is tasty. Thank you for watching.